Let's consider the second example. Now in this example we want to evaluate the path integral x squared c over a curve c, and your curve c is defined using this parameterization. X coordinate is cosine t, y coordinate is 2t, and c coordinate is sine t, and your t goes from 0 to pi. Now let's consider this line integral x squared c ds, and this equals to integral from 0 to pi of, now we want to evaluate our function f. In this case our function f is this. We want to evaluate this function f on the curve. So instead of x we should write cosine t. So we have cosine t squared, and we do not have y term, but we do have a c term, and c coordinate equals to sine t. Now this is the function value on the curve c, and then we should calculate the magnitude of c prime of t. Now let's calculate c prime of t. C prime of t equals to derivative of cosine t is negative sine t, derivative of 2t is 2, derivative of sine t is cosine t. Now what we need is the magnitude of this vector, which equals to square root of minus sine t squared plus 2 squared plus cosine t squared. This becomes square root of sine squared t plus 4 plus cosine squared t. Now if you combine sine t term and the sine squared t term and the cosine squared t term, you will get 1. 1 plus 4 is 5. Therefore this equals to root 5. Now we can update our line integral. This equals to integral from 0 to pi of cosine squared t plus sine t times root 5 dt. Of course root 5 is a constant, so let's pull root 5 from the integral sign. Now we have integral of cosine squared t sine t dt. Now to solve this trigonometric integral, we need to use a trig substitution. Now in calculus 2 we learned trig substitutions, and here we should use u equals to cosine t, then du becomes derivative of this, which is negative sine t dt. Okay, so now our integral becomes integral from, we need to find these two limits, and we will do it, we will find these two limits in a second, but let's update our integrand. Cosine t is u, therefore cosine squared becomes u squared. Now instead of sine t dt I can write, so from this sine t dt becomes negative du. This is negative du. Okay. Now let's update our limits. Okay. My variable t goes from 0 to pi, but our new variable is u. Okay, u equals to cosine t. Okay, when t equals 0, u equals to cosine of 0, u equals to cosine of 0, cosine of 0 is 1, therefore u is 1. When t equals to pi, cosine of pi becomes -1, therefore u equals to -1. Now these two limits equals to, lower limit should be 1, upper limit should be -1. Okay, and I'm going to factor out that -1, so this -1 from the integral sign. So you have -√5 times the integral from 1 to -1 u squared du. Integral of u squared is u to the power 3 over 3. Upper limit is -1, lower limit is 1. So now we have √5 times -1 to the power 3 over 3 minus 1 to the power 3 over 3. Okay, -1 to the power 3 is -1. So basically we have -1/3 minus 1/3. This becomes -2/3 times minus √5, which equals to 2 over 3 times √5.